I'll be redoing problem 1 of the first exam. So part A I actually got completely right, so there's no need to redo any of the work. But basically, to find the velocity of the intake and at the outtake, it's just a conservation of volumetric flow rate. So the volumetric flow rate is given us into liters per second, and then once you convert that into meters cubed per second, all you have to do is divide by the area of the intake or the output, depending on which one you're solving for, because it's meters cubed per second divided by meters squared, so you get meters per second. So then when you do that, you get 5.09 meters per second for the velocity in, and then 20.4 meters per second for the velocity out. Part B is where I lost some points. We want to start with the Bernoulli equation, and we're going to solve for the work of the pump. The pressure at 1 is 0 because it's at the surface, so it's atmospheric. The elevation head is 0 at 1 because it's also at the surface, and now there's a base. And then this is where I got it wrong. The velocity at 1 is also 0 because it's pulling from a large reservoir, which acts as a stationary body of water. So instead of 5.09 meters per second, this should have been 0, which I did in my new work. And then you have the work from the pump. And then on the other side of the equation, the pressure at 2 is 0 because it's coming out the outtake, coming out the nozzle, which is at atmospheric pressure. And the elevation head is 3 meters because from the problem statement it says it goes up 3 meters. And then the velocity out, which we solve for, is 20.4 meters per second. And then the head loss is 2.8 meters. That is given by the problem statement. So then all we have to do is solve for our mass flow rate, which you can solve by multiplying by the area, by the velocity, by the density, and then when you cancel all units, you get kilograms per second, and then here we have 41.2 kilograms per second. And once you input all your variables, you can solve for the work of the pump, which is 15.6 kilowatts. For part C, the reason why you don't need to know the depth of the intake pipe is because any depth it would have would be canceled out by the pressure. So if you look at the Bernoulli equation, if let's say the Z for 1 was like negative 3 meters, that'd be offset by the pressure head, which would have been just rho GH. So that's why you don't need to know the depth of the pump. It just cancels out. And then for the energy and how the energy changes, the pump gives the water mechanical energy, which is then converted into potential energy as it goes up 3 meters. Some of that energy is lost to the head loss, and then the rest of that energy is converted into kinetic as it goes out the nozzle exit. And then finally for part D, this is we have to find the force. So this is we just use momentum balance, and in the x direction, which is the way the water is shooting out, there's no external forces, no pressure, no gravity. So it's just equal to the mass flow rate times V out minus V in, which we already all solved for, and you get F of x equals 840 newtons. However, this is the force of the boat on the water, and then to find the reactionary force, you just need to multiply by -1. So it'd be negative 840 newtons to the left.